The basic construction of a submarine consists of the pressure hull, the tanks which are built around the pressure hull, and the superstructure. The pressure hull, which includes the conning tower, is the principal part. This hull must be watertight and airtight and able to resist the water pressure when submerged. The hull is circular for maximum strength and is reinforced by steel frames over its entire length. Watertight bulkheads with watertight doors subdivide the hull into separate compartments. These compartments contain all the machinery, equipment, and furnishings necessary to operate the submarine. Let's see what each compartment is used for. Amidships is the control room. The control room has the control gear for steering, diving, and operating submerged. One part is generally used as a radio room. This space below the control room is called the pump room. It contains auxiliary machinery. Next to the pump room are spaces for storing food and other supplies. Above the control room, there is usually a conning tower with the 2 periscopes and the fire control equipment. The ship is normally steered from here. Fore and aft of the control room are the battery spaces. They contain the main storage batteries which supply electrical power for operating the ship when submerged. Above the forward battery space are quarters for officers and for chief petty officers with accommodations for eating. Above the after battery space are the crew's quarters with crew's dinette and galley. This space below the crew's quarters is used as a sonar room. Aft of the crew's quarters are the 2 engine rooms. Each contains 2 main diesel engines and the generators they drive, together with auxiliary equipment. Aft of the engine room is the maneuvering room, which is the electrical control station for propelling the ship. Here are the main motors which drive the propellers. The 2 remaining compartments at either end of the hull are the forward and after torpedo rooms. There are 6 torpedo tubes forward and 4 aft. Each room has a torpedo loading hatch and stowage racks for spare torpedoes and contains bunks for some of the crew. The escape trunks are also located in the torpedo rooms. In this way, the pressure hull of a submarine is divided into compartments, each of which plays an important part in the operation of the ship. Fitted around the pressure hull are the tanks. There are ballast tanks, which control the buoyancy of the boat, and fuel tanks. The main ballast tanks are completely flooded when the boat is submerged. Some of these main ballast tanks are divided into port and starboard tanks. This is a cross-section. The tanks have flood ports open to the sea. The main vent valves control the escape of air when flooding the tanks. These are emergency vent valves. They are used in case of damage to the main vents or to prevent accidental flooding. In order for the submarine to submerge, both sets of vents must be open to flood the tanks. Since the tanks are open to the sea when submerged, the pressure is the same on both sides. Therefore, the outer skin of these and similar tanks is not made as strong as the pressure hull. In order to surface, air under pressure is admitted to blow the water from the tanks. High pressure air at first, followed by low pressure air. These two main ballast tanks operate in the same way, except that they are not divided and have no emergency vents. In addition to the main ballast tanks, there is a group of variable ballast tanks. These are used to control the trim and buoyancy of the submarine. They are the forward trim tank, the after trim tank, two auxiliary tanks, and the forward and after water-round torpedo tanks. These variable ballast tanks are only partly filled, and the seawater can be pumped from one tank to another or to sea. There are also three special purpose The bow buoyancy tank is blown to give the boat an up angle. The safety tank can be blown quickly to obtain positive buoyancy. The safety tank, seen here in cross-section, is fitted with flood valves, main vents, emergency vents, inboard vents, and high-pressure blow valves. When the flood valves are shut, this tank can be used as a standby variable ballast tank. The negative tank is a small tank located inside one of the main ballast tanks. It has a flood valve and an inboard vent. For submerging or for a rapid change of depth, this tank is flooded. As the boat approaches the desired depth, the tank is blown and the flood valve is shut. This restores neutral buoyancy. The negative and safety tanks, as well as the variable ballast tanks, are strongly constructed to withstand full submergence pressure. The fuel tanks of the submarine are also fitted around the pressure hull. These tanks contain the fuel oil for the diesel engines. The fuel tanks and the fuel system will be discussed later in this film. We have seen the pressure hull and the tanks which form the outer hull. Now the addition of the superstructure completes the submarine. Here is the bridge, which is the boat's control station when on the surface. The superstructure plating streamlines the bridge, conning tower, and periscope supports. From the deck, hatches lead to various compartments in the pressure hull. Now let's examine the principal equipment and machinery used to operate the submarine. The propelling machinery includes the units which drive the submarine through the water. Most submarines have 4 diesel engines, which are used when the boat is on the surface or snorkeling. Each engine drives its own generator. The generators provide power to the main motors, which in turn drive the propeller shafts. The generators, in addition to supplying power to the main motors, also provide power for charging the main storage batteries. The power is distributed through the main propulsion control cubicle, from where it is sent to motors, to batteries, or to both simultaneously. When submerged and not snorkeling, the main storage batteries provide the power to drive the main motors. These batteries also give power to various electrical auxiliaries and for ship's lighting. The fuel oil and compensating system delivers the fuel from the storage tanks to the engines and replaces the fuel with seawater. These tanks are used for either fuel or main ballast and are called fuel ballast tanks. These tanks are called normal fuel oil tanks. In addition, the system includes an expansion tank on the port side and a collecting tank to starboard. We can see how this system works with the help of this diagram. Each fuel oil tank is connected to the fuel transfer line, which is also connected to the collecting tank. The top of the expansion tank is connected through a manifold to the compensating water main. This main runs inside the boat with branch lines to the bottom of each fuel tank. The compensating water system also includes a line which runs from the bottom of the expansion tank through the manifold to the top side and forward in the superstructure to a header box. This header box is more commonly called a gooseneck because of its shape. The gooseneck is located in the conning tower fairwater and is open to the sea. The cooling water system of each engine is connected to the compensating water line. When the engines are running, they discharge some of their cooling water into the compensating line and keep the gooseneck filled. Of pressure in the expansion tank. This pressure is transmitted through the compensating main to the oil in the fuel tanks. Since the oil is lighter than the water, the oil always floats on top. The water replaces the oil taken from the tank on service. The water pressure forces the oil through the fuel transfer line to the collecting tank. From the collecting tank, the fuel oil passes through a purifier to the clean fuel oil tank, from which it is delivered to the engines. Note that when the submarine is submerged, the gooseneck and compensating line serve to keep the pressure inside the tanks the same as the sea pressure outside. Thus, the fuel tanks are never subjected to stress. The air supply and exhaust system provides for the diesel engine's air intake and exhaust and takes care of ventilation of the ship's compartments. When the submarine is on the surface, air is taken in through the main induction valve located in the conning tower fairwater. Starting at the main induction valve, a line runs to the forward engine room to supply engine air. A line runs to the after engine room to supply engine air. A branch of this line may go to the maneuvering room to aid in ventilating this compartment. Another line from the main induction valve to the forward engine room is the main source of fresh air to ventilate the entire hull. The exhaust gases from the engines are discharged through the engine exhaust piping, the outboard exhaust valves, and through mufflers to the atmosphere. When the submarine is below the surface, the snorkel system may be used to provide air supply and exhaust. Air is taken in through the snorkel induction mast. It passes through a water separator to the snorkel induction valve and enters the system just below the main induction valve. The engine exhaust goes through snorkel exhaust valves to the snorkel exhaust mast. The induction and exhaust masts are telescopic. When the snorkel system is in operation, They are raised so that the head valve atop the induction mast projects above the surface, and the exhaust is a few feet below the surface. To prevent flooding, the head valve is electrically controlled so that it shuts when water passes over it. The exhaust mast has a diffuser which dispels the exhaust gases, thereby reducing the telltale wake. Hull ventilation is primarily controlled by a blower in the forward engine room. It forces air along the main supply line where it passes through air conditioning units. Branch lines supply the conditioned air to the compartments. The forward battery has its own booster blower and cooling coil, which is used to supply air to the compartment and to the forward torpedo room. Exhaust lines carry the air back from the compartments to the forward engine room. If the engines are running, they use this air and it goes overboard as part of the engine exhaust. Fresh air is supplied to the blower through the line from the main induction valve. When the submarine is submerged, outside air is shut off, and the air in the hull is recirculated by the blower. At other times, the blower may use a mixture of fresh and recirculated air. The battery ventilation system provides for removal of gases generated when the batteries are on charge. Each of the main batteries gets air from the living quarters overhead. This air is drawn into the battery space, and as it circulates, it draws off the battery gases through ducts. In some installations, the ducts are replaced by an open circulation system. The exhaust air is drawn out of the battery space by battery blowers and is discharged into the main hull exhaust line. Compressed air at various pressures is used for many purposes throughout the boat. Two compressors in the after engine room compress the air to a pressure of 3,000 pounds. An external charging connection also makes it possible to take on 3,000-pound air from shore. The air is distributed through a manifold in the control room to banks of storage bottles located in the main ballast tanks. Some of it is used at 3,000 pounds, some is reduced to lower pressures before being used. This diagram of the 3,000-pound system shows a bank of storage bottles and the manifold, which is divided into a receiving section and two distributing sections. The air goes from the storage bank to the distributing sections of the manifold. From there, it is routed through piping to blow special purpose tanks, to charge torpedoes, to charge the hydraulic air flask, and to bleed air into the boat. 3,000-pound air is also used as a source for lower pressure systems. Some is reduced by normal expansion to 600 pounds and delivered to the manifold of the 600-pound air system. This 600-pound air is used to blow the main ballast tanks. Other 3,000-pound air is reduced by reducers to 225 pounds. This air is delivered to another manifold. The air in the 225-pound system is used to blow the variable ballast tanks and to do such miscellaneous jobs as blowing water from torpedo tubes, blowing sanitary tanks, and sounding the ship's whistle. Some 225-pound air is further reduced and used for a variety of jobs where lower pressures are adequate. For this reason, this system is referred to as ship's service air. In addition to these systems, an independent 10-pound air system operates from a blower in the pump room. The air from the blower is led to a manifold in the control room. Lines from the manifold lead to the ballast tanks. When the boat is surfacing, 600-pound air is used to blow the main ballast tanks until the boat gets within a few feet of the surface. 10-pound air is then used to finish blowing the tanks. This conserves the high-pressure air needed to blow the tanks at greater depths. The hydraulic system of a submarine employs oil under pressure to operate such equipment as main vents, flood valves, outboard induction and exhaust valves, the steering system, the plane system, periscope and mast hoisting systems, and many others. Oil is drawn from a supply tank by a pump. It is delivered under pressure to an accumulator. From here, it goes to various manifolds which are connected to the hydraulically operated mechanisms throughout the boat. Each manifold is divided into a supply side, which supplies oil under pressure to the mechanisms, and a return side, through which the oil is returned to the tank. An even pressure is maintained in the system by the accumulator. As oil is pumped into the accumulator, it forces a piston down. Near the bottom, the piston operates a pilot valve which actuates a bypass valve so that the oil is bypassed back to the suction side of the pump. High-pressure air from a flask is delivered to an air chamber below the piston. As the oil is used, the air pressure forces the piston upward, thus maintaining an even pressure on the oil system. Near the top, the piston resets the pilot valve, which actuates the bypass valve, so that the pump again forces oil into the accumulator. This non-return valve maintains the pressure on the system when the pump is discharging through the automatic bypass or when the pump is shut down. The submarine's trim system is used to shift seawater ballast for fore and aft trim and for control of buoyancy. It consists of a trim pump, a trim manifold in the control room, and lines from the manifold to the variable ballast tanks, the negative tank, the safety tank, and to sea. This trim system makes it possible to pump water from any variable ballast tank to sea, or from the sea into the tanks, or to shift water from any one of the variable ballast tanks to another. The drain system provides for pumping of bilges. Lines from the bilges lead to a drainage line running the entire length of the submarine. The drain pump draws water from the drain line and discharges it overboard, or to the trim system, or to the fuel oil compensating system. If the water is discharged to the compensating system, oil in the bilge water will be separated out in the expansion tank, preventing telltale oil slicks. The drain pump also has a connection to the bottom of the collecting tank for the pumping of that tank when necessary. There are interconnections between the drain and the trim systems so that either pump can be used for either system. We have seen the most important equipment and machinery necessary for the operation of the submarine. The propelling machinery, which consists of the main engines and their generators, and the main motors, which drive the propellers. The engines are used to provide power for the motors when the submarine is on the surface or snorkeling. Batteries power the motors when submerged. The fuel oil and compensating system delivers fuel oil to the engines and replaces used fuel with seawater. The air supply and exhaust system supplies the air needed to run the engines, it ventilates the boat, and it removes engine exhaust gases. The snorkel system provides for air intake and exhaust when the boat is submerged. The battery ventilation system removes gases from the batteries. The compressed air systems distribute air furnished by two compressors. The air is stored in banks at 3,000 pounds pressure. This air is used directly or at reduced pressures to blow tanks, charge torpedo impulse flasks, and for general ship's service. The 10-pound air system is used to blow the residual water from the main ballast tanks when the ship is surfacing. The hydraulic system operates main vents, valves, and other hydraulic gear throughout the ship. The trim system is used primarily to distribute weight in the boat for fore and aft trim or overall buoyancy. The drain system is used primarily for pumping bilges. The construction of the modern submarine employs the latest developments in science and engineering to make it a formidable weapon against the enemy.